Okay, Assalamualaikum warahmatullahi wabarakatuh. Now we come to the last part of chapter 2, which is solving system of linear differential equations by elimination. Okay, when we have to use this technique or method. Okay, when we have simultaneous ordinary differential equation which involves two or more equations that contain derivatives of two or more dependent variables. Okay, actually, the method of systematic elimination for solving differential equation with constant coefficients is based on the algebraic principle of elimination of variables. Okay, we know the standard form of linear differential equation. Okay, the standard form an y power n plus a n minus 1 y to the power of n minus 1 plus a1 y prime plus a naught y equals to gt. Okay, this equation is homogeneous when gt equals to 0. If gt equals to non-zero, this will become non-homogeneous. Okay, to solve the linear differential equation, if we have simultaneous linear differential equation, okay, to solve by elimination, first we need to rewrite the equations. Okay, rewrite the equations in the system in differential operator notation. Okay, this is the equation in differential operator notation. So a power n d power n plus a n minus 1 d n minus 1 plus a 1d plus a naught y equals to gt. Okay, sorry, for actually here in the standard form of linear differential equation, and here is actually the order of derivative. This is the order of derivative. Let's say if we have second order derivative, so equation will become a2 y double prime plus a1 y prime plus a naught y equals to gt. Okay, this is the second order. Okay, if we have second order linear differential equation, okay, to transform it into operator notation, so it will become, let's say we have second order, so a square, a2 d square plus a1 d plus a naught y equals to gt. So this is the power here, show the order of derivative. Okay, there are several steps to solve the equation which involve simultaneous ordinary differential equation. Okay, for example, For example, if we have two equations, the first one is dx over dt equals to 4x plus 7y. And the second one is dy over dt equals to x minus 2y. So we have the simultaneous equation. Okay, first step, we have to move all terms involving an x or y to the left hand side. Okay, so the equation will become dx over dt minus 4x minus 7y equals to 0. And the second equation will become dy over dt minus x plus 2y equals to 0. Okay, now we come to the second step. Okay, rewrite the system. In operator notation. Okay, dx dt here is the first order derivative. For first order derivative, so the operator notation will become d. This is also first order, so it's become d. Okay, so for equation 1 here, dx over dt, so d minus 4x minus 7y equals to 0. Okay, since d here is dx over dt, so we can combine with 4x. So equals to d minus 4x minus 7y equals to 0. Okay, this is the first equation. Okay, for the second equation, okay, dy over dt, so d minus x plus 2y equals to 0. Okay, actually here dy over dt, for second equation, dy over dt, so it's in terms of y, so we can combine d here with y, 2y. So d plus 2y minus x equals to 0. So this is equation number 2. Okay, then the third step, solve the system by elimination. Okay, first, we want to eliminate x. Okay, refer to the first and second equation. Okay, how to eliminate x? Okay, look at the first equation, we have d minus 4x. But for the second equation, we only have negative x. So, equation 2, we need to multiply with d minus 4. So first, we need to multiply equation 2 with d minus 4. Okay, so now the equation become Okay, the first equation remain the same. D minus 4 x minus 7y equals to 0. Okay, remain the same. But for equation number 2, when we multiply with d minus 4, it's become d minus 4 d plus 2y minus d minus 4 x equals to 0. So now it's become the equation number 2. Okay, to eliminate x, okay, look at equation 1 and 2 here. Okay, to eliminate x, so we have to add equation 1 with equation 2. So then we can eliminate d minus 4x and for both equation. So equation 1 plus equation 2. So now we can eliminate the term with x. So we only have y. So we have negative 7y plus d minus 4 d plus 2 y equals to 0. So negative 7y plus, okay, this we can expand. It's become d square plus 2d minus 4d minus 8 y equals to 0. This is 7y and here negative 8y. So we can add 7 minus 8 is negative 15. So we have d square. So 2d minus 4d equals to negative 2d minus 2d minus 15 y equals to 0. Okay, now we have second order derivative, so we can transform into auxiliary equation. Okay, auxiliary equation is m square minus 2m minus 15 equals to 0. Okay, from this we can get the roots by using the equation. Okay, m equals to negative b plus minus square root b square minus 4ac over 2a. Okay, this is a, negative 2 here is b, and negative 15 here is c. Or you also can use your calculator to find the roots. So our m equals to 5, and another one m equals to negative 3. So we have real and distinct root. Okay, for real and distinct root, the general solution, so since this is in terms of y, so yt equals to c1 e to the power of 5t plus c2 e to the power of negative 3t. So this is our yt. Okay, now we have to eliminate y. Okay, we repeat the same step, same like how to eliminate x. Okay, refer to the first equation. Refer to the first equation. Y, in the first equation we have negative 7y. Here negative 7y. But for equation 2 we have d plus 2y. So to eliminate y, we have to multiply equation 1 with d plus 2, and equation 2 we have to multiply with 7, since here we have 7 coefficient here. So we have, okay, first to eliminate y, we have to multiply equation 1 with d plus 2. So equation 1 will become d plus 2 d minus 4 x minus 7 d plus 2 y equals to 0. Okay, this is first equation. Okay, now the second equation, we have to multiply with 7, since we have 7 in front here. So we have to multiply second equation with 7. So it's become seven d plus 2 y minus 7x, 7d plus 2y minus 7x equals to 0. So this is our new equation number 2. Okay, to eliminate y, so we have to add equation 1 with equation 2. So we have to add equation 1 with equation 1 and 2 to eliminate the term with x. So equation 1 plus equation 2, now it's become d square minus 2d minus 8x minus 7x equals to 0. So d square minus 2d minus 15x equals to 0. Okay, now this is second order derivative or second order differential equation. So we can transform into auxiliary. Auxiliary equation. So it's become m squared minus 2m minus 15 equals to 0. So the roots, we have the same roots with the previous one when we eliminate x. So m equals to 5 and another m equals to negative 3. So our general solution is xt equals to C3. Okay, since we already have C1 and C2, so now it's become C3 e to the power of 5t plus C4 e to the power of negative 3t. Okay, this is our xt. Okay, the next step, step number 4, we have to substitute xt, yt, x prime t into the original equation. Because we want to have only two coefficient or two constant, C1 and C2. Okay, we have original equation dx over dt equals to 4x plus 7y and dy over dt equals to x minus 2y, and we already have xt equals to c3 e to the power of 5t plus c4 e to the power of negative 3t. Okay, to substitute xt, yt, x prime t into the original equation, okay, first we have to let get this dx over dt. Dx over dt actually is x prime t, meaning we have to differentiate xt. So our x prime t, okay, we differentiate xt, we get 5c3 e to the power of 5t minus 3c4 e to the power of negative 3t. This is our x prime t. And we also have yt equals to c1 e to the power of 5t plus c2 e to the power of negative 3t. Okay, we put it as this is A, equation A, and this is equation B. Okay, we have to substitute all this into equation A. So dx over dt is x prime t. Okay, our x prime t is 5 c3 e to the power of 5t minus 3 c4 e to the power of negative 3t equals to 4x. Okay, this x actually xt, so we can substitute with the xt. So c3 e to the power of 5t plus c4 e to the power of negative 3t plus 7y, 7, and y here is actually our yt. So c1 e to the power of 5t plus c2 e to the power of negative 3t. Okay, so we group together the terms with exponential to the power of 5t. So 4c3 plus 7c1 e to the power of 5t plus, okay, and we group together the terms with exponential to the power of negative 3t. So 4c4 plus 7c2 e to the power of negative 3t. Then we can compare left hand side and right hand side. So 5c3 e to the power of 5t minus 3c4 e to the power of negative 3t. So the terms with e to the power of 5t here, so we have e to the power of 5t here, so 5c3 equals to 4c1 plus, 4c3 plus 7c1. 5 minus 4 is 1. So C3 equals to 7 C1. So we have C3 equals to 7 C1. And another one is negative 3 C4 equals to 4 C4 plus 7 C2. So negative 3 plus 4 equals to, negative 3 minus 4 equals to negative 7 C4 equals to 7 C2. So C4 equals to negative C2. So now we have C4 equals to negative C2 and C3 equals to 7 C1. So we can substitute C3 and C4 into the equation. So our xt actually C3, okay, our xt actually C3 e to the power of 5t, but since we have already here C3 equals to 7 C1, so it's become 7 C1 e to the power of 5t minus, okay, since our C4, so C4 here we already have, the new one is negative C2, so minus C2 e to the power of negative 3t, and our yt remain the same, C1 e to the power of 5t plus C2 e to the power of negative 3t. So instead of we have C1, C2, C3 and C4, now we only have C1 and C2. So that's the final answer. Okay, that's all. Thank you.